Okay, here we are with lesson 4 and our second part on writing products as sums and sums as products. So for example 1 in your journal, go ahead and copy this table down. Write equivalent expressions using the distributive property for the first 4 problems. And go ahead and stop the video, copy this down because it's going to go away on the next slide. Alright, you should have these copied down. So you're finding the equivalent expressions using distributive property. And then try to go backwards and write equivalent expressions for the last 4 problems. And the hint is, what is the common factor in each term? So as you look at these 2 terms, what do you notice is a common factor that can be essentially pulled out of each term? So what is happening when we go backwards to find equivalent expressions for the expressions in E, F, G, and H? Well, in the same way dividing undoes multiplying, factoring undoes expanding. So what are the terms being divided by? Well, they're being divided by a common factor. So write the equivalent expression to 8 times x plus 4. Well, would it be incorrect to factor out a 2 instead of a 4? Well, it would not be incorrect, but in order to factor completely, we would need to factor out a 2 again. Mathematicians have decided that factoring generally means factoring with the greatest common factor of terms. So if we have 8 times x plus 4 using the commutative property, well then we can write an equivalent expression because 8 is the same as 4 times 2, x, and 4 is the same as 4 times 1. And then, since we have a common factor of 4, we can factor that out and we're left with a quantity of 2x plus 1. It's the same sense in finding equivalent fractions. Usually we're asked to simplify fractions to its lowest terms. So if we had 15 tenths, we would still factor it out to taking out a 5, which is the greatest common factor of 15 tenths. Alright, so take a look at exercise 1. Go ahead and complete it before continuing the video. Alright, you should be done with exercise 1. And you should have something that looks similar to this. Rewriting the expressions as a product of 2 factors. The greatest common factor we can take out of 72 is 8. Yes, you could take out a 4 or you could take out a 2, but 8 is the greatest common factor, so it would be 8 times the quantity of 9t plus 1. For here, 36 is the greatest common factor. For E, it's 3. For B, it's 11. And for D, it is 3. Alright, so let's take a look at example 2. We're going to use a rectangular arrays like in the previous lesson. But this time we're going to work backwards. So we're given the information inside of the rectangles. And now what does 2x represent in this first rectangle above? Well, that it's a rectangle that has an area of 2 times x or can be covered by 2x square units. So what does the entire array represent? Well, the entire array represents that's 2 times x plus 12y plus 8 square units. And what is the common factor of 2x, 12y, and 8? Well, the common factor for these 3 terms is 2. So what are the missing values and how do you know? Well, the missing values are x, 6y, and 4. If the products are given in the area of regions, divide the regions by 2 to determine the missing values. So, since it is double x and double 6y and double 4, our factor is 2, so that 2 times x is 2x, 2 times 6y is 12y, and 2 times 4 is 8. So write the expression as a product of two factors and then as a sum. Well, the product of two factors would be 2 times the quantity of x plus 6y plus 4, and the sum would be 2x plus 12y plus 8. So how does this exercise differ from the exercise we did in the previous lesson? How is this exercise similar to the ones we did in the previous lesson? Well, we are doing the inverse of writing products as sums. Before, we wrote a product as a sum using the distributive property. Now, we are writing a sum as a product using distributive property. So in this essence, this multiplication problem is the same as this addition problem. All right, go ahead and complete exercise 2 on your lesson worksheet and then continue the video. All right, you have exercise 2 completed. It should look something like this. So write the product and sum of the expressions by representing the rectangular array. So this would be 2 times the quantity of 12d plus 4e plus 3, or you can write it as 24d plus 8e plus 6. Then it asked to factor 48j plus 60k plus 24 by finding the greatest common factor of the terms. Well, the greatest common factor of 48, 60, and 24 is 12. So that means that the product of 12 times the quantity of 4j plus 5k plus 2. All right, let's take a look at exercise 3. We're going to do the first row together. So for each expression, write the sum as a product of two factors. Emphasize the importance of the distributive property. Use various equivalent expressions to justify equivalency. So for A, we have 2 times 3 plus 5 times 3. For B, we have the quantity of 2 plus 5 repeated 3 times. And for part C, we have 2 times 2 plus 5 plus 2 plus 5 times 2. So for part A, both of them have a common factor of 3, so the two factors would be 3 times the quantity of 2 plus 5. We can demonstrate that 3 times 7 is equivalent to 6 plus 5, or 15, which is 21. So that's what they mean by justifying equivalency, is to just go ahead and solve it. So in this case, 3 times 7, which is 21, is the same as doing 2 times 3, which is 6, and 5 times 3, which is 15, and 6 plus 15 equals 21. All right, so how does that compare to part B? Well, again, we have 3 groups of 2 plus 5, or you can also write it as 3 2s and 3 5s. So therefore, you get 3 times the quantity of 2 plus 5. And last, for part C, rewrite the expression. Well, we can pull a 2, or factor a 2 out. So this would be 2 plus 2 plus 5, or 2 times 2 plus 5, which is, again, 3 of them. So if you have 2 of these plus a 5 plus 2, or 2 plus 5 as they turn it around, then it still is the equivalent of 3 times the quantity of 2 plus 5. All right, for the rest of them, you should have something that looks similar to this. Again, the same concept for D, E, and F. What can you combine or factor out? So go ahead and compare the rest of these and write down any additions that you need to make to your paper. All right, you should be caught up all the way to part I. So let's continue with example 3. So read the problem and think of 2 ways to write an algebraic expression to represent this. Well, one way is 6 times the quantity of 2 times g plus 20t minus 3. Each person will pay for 2 rounds of golf and 20 tokens and will be discounted $3. This expression is 6 times the quantity of each of the friends' costs. But another way is we can write this as 12G plus 120T minus 18. The total cost is equal to 12 games of golf plus 120 tokens minus $18 off the entire bill. All right, example 4, we're going to do in your journal. So what does it mean to take the opposite of a number? Well, you can determine the additive inverse of a number or the multiplicative inverse. So what is the opposite of 2? Well, that would be negative 2. So what is negative 1 times 2? Well, that would still be negative 2. So what is negative 1 times some number, which we'll call n? Well, that would be negative n. So what are two mathematical expressions that represent the opposite of the quantity of 2a plus 3b? Remember, look up here at the top as to what's going on to see if you can figure this out. Well, we can multiply the quantity of 2a plus 3b by negative 1, or we can just say take the opposite of the quantity of 2a plus 3b. Remember, going back to this right here, taking the opposite of a number, which is negative 2, is the same as multiplying that same number by negative 1, which also gives us negative 2. So use the distributive property to write negative 1 times the quantity of 2a plus 3b as an equivalent expression. Well, we would get negative 2a minus 3b, or negative 2a plus the opposite of 3b, which is negative 3b. So again, that whole idea of taking subtraction and turning it into adding the inverse. So to go from negative 2a minus 3b to the opposite of the quantity of 2a plus 3b, what process occurs? Well, the terms negative 2a and negative 3b are written as negative 1 times 2a and negative 1 times 3b. And the negative 1 is factored out of their sum. All right. Go ahead and complete exercise, should be 4, and then continue the video. All right, so you're done with exercise 4. What is the opposite of the quantity of negative 6v plus 1? Well, that means we take the opposite of it, so the opposite of the quantity of negative 6v plus 1. So now, using the distributive property, write the equivalent expression for part A. Well, again, this is the same thing as either multiplying by negative 1 or just saying take the opposite of negative 6v. Well, the opposite of negative 6v is positive 6v, and the opposite of positive 1 or plus 1 or adding 1 is to subtract 1. All right, example 5 on your worksheet. Together we are going to rewrite 5a minus the quantity of a minus 3b. Applying the rules for subtracting and what we did in example 2. So for the first step, we want to add as this, we want to change subtraction into adding the inverse. So we're doing one thing at a time. Right now we're focusing on this minus 3b. So 5a plus the opposite of taking the quantity of a plus, and then we want to write this as negative 3b. Now, I would put the negative 3b in parentheses because we don't want two signs together. So now, the opposite of a number is the same as multiplying by negative 1. So factoring out, or changing this opposite to a negative 1, says that we are going to multiply this quantity by negative 1. So that means we're going to multiply a by negative 1 and negative 3b by negative 1. which is going to be the distributive property. So in that case, the opposite of A is negative A, and the opposite of negative 3b is positive 3b. And this is the same as multiplying by negative 1, and that is the same as taking the opposite of a number. And then collecting like terms, 5a plus a negative a is 4a, and then we have plus 3b, and therefore that is its own term. So from this beginning expression, we can simplify this down to 4a plus 3b. All right, so go ahead and complete exercise 5. Expand each expression and collect like terms while applying the rules of subtracting and the distributive property. Write the rule next to each step like in the previous example and then continue the video. All right, so you should have something that looks like this. First step is turn the subtraction back to adding the opposite, which is subtraction is the same as adding the inverse. And then go ahead and use the distributive property. Multiply the factor times what is inside the other factor. So negative 3 times 2p and negative 3 times negative 3q. And then go ahead and apply the integer rules. Well, negative 3 times positive 2 is negative 6, and negative 3 times negative 3 is positive 9. So this is where we got here. And then the same thing, taking the opposite of the quantity of a minus b, and a minus b is the same as a plus a negative b. Well, that's the same as multiplying by negative 1, so a becomes negative 1a, and negative 1 or negative b becomes negative 1b. And then applying the distributive property, so this becomes negative 1a, this becomes positive 1b, and therefore collecting like terms, negative 2a plus a positive b. All right, so in writing products as sums, what is happening when you take the opposite of a term or a factor? Well, the term or factor is multiplied by negative 1. When using the distributive property, every term inside the parentheses is multiplied by negative 1. Describe the process you use to write an expression in the form of a sum of terms as an equivalent expression in the form of a product of factors. Well, writing sums as products is the opposite of writing products as sums. So instead of distributing and multiplying, the product is actually being factored, or in some cases, if you want to think of it, being reduced to simplest terms. All right, we'll see you in class.